Hello, class. So this is year 2004 questions. Now let's get started. So here we have traffic flow is defined by this function, as you can see. Now, which car passes through the intersection? Through an intersection? Cars per minute. You see, the per represents the rate. Now, the traffic flow at a particular intersection given in this way. Now, let's try to look at it. Once again, cars per minute talks about the rate, and t is the time. In this case, is in terms of the minute. Now, first question is this: how many cars from cars per minute? Now, cars per minute can be considered as the derivative in one way because it talks about the rate. How many cars? Therefore, in order for us to get that, we have to get the antiderivative. So therefore, in order for us to do A, what we'd like to do is this: 82 plus 4 sine of t over 2 dt from 0 through 30. Right now, let's try to put that into our calculators. As you can see right here, we will put y equals, we're going to clear first, we have 82, and I believe it was plus 4 sine of, in this case, we're just going to write down x over 2 instead of t over 2, right, from 0 to 30. Now, then I'm going to set the window as, I'm just going to call it -1, a little bit less than that, and then 31, a little bit more than what we want. And we can always go for zoom standard here, number 6. Oh, I mean, what am I doing? Zoom fit, that's what I wanted to do, sorry. -1 to 31 for zoom fit, right over there. And we should have a nice curve that goes along this way. Now, since we're trying to get the integral, what we like to do is second, calculate an integral number 7. Our lower limit was equal to 0, upper limit was equal to 30, then we should be able to get our answer. All those areas coming together. Now, I'm going to drag this one right over here. So as you can see from this picture, our answer will be this value. So approximately 2474.0775. Now, but they want us to write it to the nearest whole numbers, so we could have 2474 cars. That's our answer for A. Now let us go for number B. Is the traffic flow increasing or decreasing? Now, when you look into this one, traffic flow is increasing. Now, the word increasing or decreasing implies derivative. The traffic flow, in fact, is that function that's given already. Therefore, since this is a flow, is the flow increasing or decreasing? We have to find the derivative. In order for us to find the derivative, B, we are looking for f prime of 7. Since the time is 7, we'll have to go back to the calculator, and we'll calculate second calc. And number 6, as you can see over there, and then the value was 7. X was equal to 7. Then we realize here we realized that f prime of 7 is this number right here, approximately negative 1.87. Now, so give a reasoning for your answer. Since f prime of 7 is negative, as you can see over here, the flow is decreasing. All right, there it goes. That's number B. Number C, what is the average value? Now, when we're talking about average value, we're talking about integral usually. Now, average value of the traffic flow, that means we need to get the integral of this function. Now, that would be number C. I like to do it green then. So we like to get the traffic flow average value from 10 through 15. So we have 10 through 15 of the function f of t dt. I'm just going to use f of t in place of all these things instead of writing it every single time. And then by the formula for the average value, we have to divide by 15 minus 10. Now we can calculate this one from the previous one over here. Let us try to recalculate it now. After we correct it, then second calc, once again number 7. What is our lower limit? Lower limit was 10. What was the upper limit? Upper limit was 15, if you remember. And we end up getting 409. Now, let me drag this one out for you. So, this value that we have, integral value, is 409. Now, in our calculator, we can still retrieve this value. I'm going to quit. And if I simply do the second answer, which is the last calculated value, that was that, and we have to divide that by 15 minus 10, which we know that to be 5, and that will become our answer. So, our answer will be 81.90. Now, did they say about the unit? Indicate the units of measures. Since the traffic flow was in terms of cars per minute, average value will still be the cars per minute. Another way of looking at it is cars, integral gets you the number of cars, divided by the word per implies the division. Minute comes from 15 minus 10. So there it goes. That's our C. Now let's go for D now. What is the average rate of the average rate? Average rate is basically the slope of the secant line. You see? Average many times represents the slope of the secant line. Now, average rate of the change of the traffic flow. Basically, we're talking about the same thing, but we're looking at the slope between these 2 points. So therefore, number D here will end up getting f of 15 minus f of 10. You see, divided by 15 minus 10. As you can see right here, these two values are different from these two values. So we're going to use the calculator to try to calculate this one more time. Now, second calc. We're going to find that the value. So, what's the value of x? When it was 15, what was the value right here? Now, since y value is this, what I'm going to do is this. I'm going to assume that to be store. Let's store that into A. I believe that was the value, 81.89. Oh, no, not really. I'm sorry. Y value was that, wasn't it? So instead of that, we have to get the y value. I believe y value was 85. Yes. Previously, if I were to do that one more time. Yes. So since y value was that value, I'm going to store that into our new A. Now, and then likewise, we're going to calculate number 1 once again, and then second value was what if x was equal to 10. We have y value 78. So what I'm going to do is I'm going to just retype y just to make sure. Y is 78, the value that we wanted. Now I'm going to store that to b. Then here, this calculation simply becomes a minus b on my calculator divided by 5. So we have a minus b, which is that value divided by 5. And that becomes our answer. So our answer would have been 1.518. Now, indicate the units of measure. So you see the traffic flow already had cars per minute. But we are dividing it by another change of the minute, so we gotta square the minutes. That would have been our final answer for number 1. All right, let's move on to number 2. Here we have f of x and then g of x. F of x is given in this way, 2x times 1 minus x, and gx is given in this way. All right, so let us try to put these two functions into the graphing calculator first. What I'm going to do is I'm going to erase this one. I'll say 2x times 1 minus x, I believe. That was the function. Second one is 3 times x minus 1. 3 times x minus 1, and then square root of x. Alright, so that's basically what we have. The first one is the f of x, and second one is the g of x. F of x was on top and g of x was on the bottom. It looks like the intersection seems to be 0 and 1. Now, first the question is this: find the area of the shaded region. Now, shaded region, getting the area is relatively simple. So all we have to do is, since area is defined from 0 through 1, and then height of each rectangle that we see would have been f of x minus g of x. So I'm just going to write it this way. How are we going to calculate that? In our case, unhighlight both of them. And the only thing that I'm going to highlight would have been y was function. All right, there it goes. Y sub 1 minus, same thing, y was function. All right, y sub 2. And here we have the value is going from 0 to 1. So let us set the window maybe from -1 to 2, so we could have a nice picture. And zoom fit 0. All right, there it goes. Now, then we need to find this area. Second calc. Number 7 integral. Lower limit was 0. Upper limit was equal to 1. And there it goes. All right, our answer is 1.133. All right, so is there any unit? I don't think so. Then we are okay. Number B, find the volume of the solid generated when shaded region is revolved around y equals 2. Now we know that y equals 2 would have been way on top. I'm just going to assume that it's, I know that it's scale, it doesn't, in terms of scale, it doesn't make sense, but let us say that y sub 2 is way on top over here. And since this one is revolved around that, what's going to be happening is, what is our longer, bigger R? Bigger R goes from here all the way down to here. Now, since this will be the difference between 2 and g of x, the big R, in fact, will be 2 minus g of x. How about the small r? Goes from here to here, which we need to subtract. Small r becomes then 2 minus f of x. You see? Now that's basically what we end up getting. So knowing that, number B, volume will be pi from 0 to the 1. Bigger radius, now we know that to be 2 minus g of x squared minus 2 minus f of x squared dx. Now that is the expression from the bigger volume, outer volume, minus the inner volume right here. Now, then using the calculator once again, so we're going to have pi times. All right, and then we have 2 minus, let me just put this one once again, 2 minus y sub 2 close it up. Now, right, so we are continuing. So here we have and then minus, we got to square that, minus smaller radius, which is 2 minus y sub 1. All right, close the parentheses. So that's basically what we have. Outer volume minus the inner volume, right? Making a whole. Now we're going to graph that one more time of some sort. And we know that the volume has to, the boundaries are from 0 to the 1. Second, calc 7, lower limit is equal to 0. Upper limit is equal to 1. All right, there it goes. So our answer is right over here. 16.179. Now, they didn't say anything about making some sort of approximation, so I'm just going to leave it like this. Right? Now, number C. I will do number C with blue. Let h be the function given in this way. All right. Some sort of function which looks like the other stuff. Now for k is positive. Now enclosed by the graph h and g. Now you see f of x looks very similar to h of x. Only difference between h of x and f of x is that h of x has a constant k instead of 2. So it can be this way or any other way for that matter, I guess. Now, and then now we have here base of the solid with the square cross section. Notice the square. Square is simply what? One side square. That's how we find the area. Collection of that becomes a solid here, perpendicular to the x-axis. There's a value k for which the volume of the solid is equal to 15. Right, but do not solve. Okay, so we just have to find the integral, and then we just have to set it equal to 15. Now, when you look at the graph, chances are the graph will look somewhat similar to before, as in one graph will look like this. The other graph will look like this. Like, since k is positive, it's k the one that h of x will be on top, and then g of x will still be on the bottom. Notice that here, this one versus this one, they are opposite to each other, isn't it? That means this is somewhat of, has a negation concept embedded in it. Now, therefore, it goes to the under the x-axis. Now, then the fact that we have some sort of square embedded in this case, square cross-section, and I'll attempt to draw the 3D picture. Imagine this is a square, and then this square will be, continuing throughout whole section from here to here. Now, you will realize that even h of x in k times x times, I believe it was, yes, 1 minus x. There's two locations where h of x will be equal to 0, which is when x equals 0, which is right over here, and when x equals 1, which is right over here. So same boundaries. Then, how are we going to find the volume? Volume here has to be equal to 15, which goes from 0 to the 1. Now, what is the length of one side of the square? In fact, it will be simply h of x minus g of x. So in this case, I believe they wanted us to find the value of k. So instead of writing h of x, I'm going to write down this expression itself, in fact. So I'm going to write it as k x times 1 minus x. That is the upper line, and the lower line will be g of x minus g of x. That will be the length of one side of the square, and as you square them, it becomes the area, and summation right here, collecting all those squares, will end up getting the volume with the thickness of dx. There it goes, that's it. Alright, let us move on. Number 3. A particle moves along the y-axis so that the velocity, now in this case we are moving on the y-axis. We've been solving many times particle moving along the x-axis, but it's essentially the same thing. Now velocity is given here. At time t is equal to 0, y is equal to negative 1. Now notice that this is the initial condition, you see. Initial condition. Initial condition usually deals with the value c, value of the c constant when you take the antiderivative of this one. But we'll see what happens here. Find the acceleration. Now, in order for us to find the acceleration, since the calculator is still allowed, we're just going to put that in and then find the derivative of v, which is the acceleration. So here it goes, a. Acceleration when time is equal to 2 is in fact velocity, derivative of the velocity when t is equal to 2. So let's try to put that in. I'm going to clear everything for now. Here we have 1 minus arc tangent, second tangent of E right over here of x. Instead of t, we just put down x. Doesn't matter actually. Now, what is the boundary? Boundary seems to be t has to be greater than 0, and then it has to include at least 2. So what I'm going to do is I'm going to set the window from -1, which is fine, but I'm just going to put the x max as maybe how about 5, and I'm going to just zoom fit. All right. Now, we're taking the acceleration, which is derivative of the velocity, so we're just going to get the second calc, number 6, right over here. And the value was 2. There it goes. Here we realize the value would have been about negative 0.13, and then rounding to 3, I guess. Now here, I don't see any units, so I'm just going to leave it like that. Now B. I'm going to try to use the red marker. Is the speed, notice speed is the what? Absolute value. And then is speed increasing or decreasing? Now speed being increasing and decreasing depends all on the signs of velocity versus acceleration. If they have the same sign, velocity and acceleration, then it's like a acceleration associated with force. It's like pushing the object in the same direction. So when they have the same signs between acceleration and then the velocity, then it will speed up. Now, but if they have the different directions, meaning different signs, then speed will decrease. It will slow down. Now, we know the acceleration was negative 0.133. How about the velocity? We're going to go here, value, and x equals 2. And you realize that velocity is negative 4.3. All right. Now we have to give we have to write down give a reasoning for your answer. Now we realize that v of 2 is equal to also negative 4.36. Reasoning can be since a sub 2 and v sub 2 are or have the same sign, meaning both of them are negative. The particle is increasing its speed. All right, so we can write something similar to that. Now, number C, find the time t is greater than 0 at which the particle reaches its highest point. Highest point basically means farthest above the values. Now, highest point, how can we get the highest point? Let us try to look into this one. Highest point basically means maximum y value. Maximum y value, we have to get the, let's go down. Right here. Highest point simply means it's got to be the maximum. How can you get the maximum? From its first derivative. The first derivative, meaning the first derivative of the position, meaning the velocity, has to go from positive to negative. Where do you see the velocity go from positive to negative? It's right here. At this point, which is right over there. As long as we find that particular point, you will realize that the particle is at the highest point. So let us try to look into that. How can we find that one? Second, calc 0. Left bound, I can just trace back and forth, but I can just type in 0 gotta be less than this one, obviously. And then right bound seems to be this seems to be 1, so I'm just going to type in 1. And guess yes. There it goes. So we have when t, same thing as x in this case, is equal to 0.443. So there we have it. When t is equal to 0.443. Let me go back, read the rest of them. Find the time t. Okay. And justify your answer. When t is equal to 0.433, velocity is equal to 0, meaning especially goes from positive to negative. The particle changes its direction as it marks the highest place. Alright, now the key component is velocity goes from positive to negative. Alright, now, and then as you can see, it will never come back up, and going another, there's no other maximum point anyway, so that's gotta be the answer. Now, that was C. Now let's go for D. I'll use the green. Find the position of the particle at time t is equal to 2. Now, we can find the position knowing that originally position was -1. So now, we can approach this one in a couple of different ways. Intuitively, how can you find this? This simply means integral from 0 to 2 for v of t dt. This one gets the change in displacement. But this one has to be only add on to y sub 1, because from y sub from 0, y sub 0, when t was equal to 0, where was the particle? And then when you add on to the displacement, whatever happened from 0 to 2, that would have been position 4, the particle when time is equal to 2. Now, have we calculated this one already? I don't think so. So let us try to calculate that for a second. Alright, so second, calc. Number 7, lower limit was 0, upper limit was equal to 2. Notice the net change from 0 to 2 would have been this. Now, so therefore, this portion would have been equal to negative 0.361. Plus y sub 0 was equal to 1 previously, or -1 rather. Our final answer would be negative 1.361. That becomes our final answer. Now, is the particle moving towards the origin or away from the origin? Now, since the location of the particle is below the x-axis, because it was a negative value right here. Now, well, what's happening to the velocity? As you figured it out, velocity, when t was equal to 2, right here, was equal to negative also. That means it is further going down. So, the particle is moving away from the origin, because velocity when time was equal to 2 is less than 0, and position y sub 2 was less than 0, simply put. Now, that's it. Number 4. Let us try to look into this question. We just have to show that this one, when you take the derivative against y, dy over dx, we would have gotten this one. You can easily see that this one has an implicit differentiation. So let us try to get started. When you take the derivative of x squared, we get 2x. Second one, plus 8y times y prime equals 7 becomes 0, and 3xy simply becomes 3xy prime plus 3 y. That's the derivative of x. Okay. Derivative of 3xy respect to x. Now, so that's what we end up getting. And as we move all the terms with the y prime on one side, then we end up getting 8y y prime minus 3xy prime, which is equal to 3y minus 2x. As we factor out y prime, 8y minus 3x, which is equal to 3y minus 2x. Then what is y prime, which we know that to be dy over dx in this case is equal to 3y minus 2x all over 8y minus 3x. And that is what they asked us to find. Alright, number B, show that there is a point P with x coordinate 3. Now x coordinate is 3, but at which the line tangent to the curve is horizontal. Tangent is horizontal. That means the slope is equal to 0. Now, how can we find that? So B, horizontal implies y prime is equal to 0. That means 3y minus 2x over 8y minus 3x has to be equal to 0. How can you have the fraction to be equal to 0? Well, simple, when the numerator is equal to 0. So this simplifies into 3y minus 2x is equal to 0. But notice, they mentioned that x was equal to 3 already, so therefore in place of x, I will write down 3. Then we end up having 3y is equal to 6, where y is equal to 2. So we found the y coordinate of that p value. All right, number C. We need to find the double derivative of that point. The point P, which means we have to use the coordinate 3, 2. That is the point P value. Now, after finding that out, we will figure out if it has local maximum or minimum or neither, and we'll try to justify the answer right after. Now, C. Since dy over dx was equal to 3y minus 2x over 8y minus 3x. What we like to do is this, as you mentioned before, we're going to take the second derivative. That means we got to start from here. As you take the derivative one more time, second derivative now becomes, denominator will be 8y minus 3x squared. Now, what are we going to do? Take the derivative of the top, which ends up being 3y prime minus 2 times 8y minus 3x minus, we're going to write down the top once again, 3y minus 2x. Alright, so we're continuing here. So at the end, we have to take the derivative of the bottom. We end up getting 8y prime and minus 3. When you look into this one, this seems to be quite complicated in plugging in 3, 2 in all of the place. But notice, y prime was already equal to 0, as we have done. That means here, this portion will be equal to 0, and then this portion will be equal to 0. But when we make the derivative of this one equal to 0, notice that 3y minus 2 was equal to 0 too, isn't it? That's how the fraction becomes 0. That means whenever we see 3y minus 2, this whole thing becomes 0. That means this part simply becomes 0. Now, only thing that which we have to do is this. Now notice another thing here is 8y minus 3x is common here, and then negative 2. So this cancels out with one of the factor, and at this particular location, at this particular point, we end up getting negative 2 on top, on the bottom, times 8 times y was equal to 3, minus 3 times x equals 2. Not bad, right? So we have negative 2 over 24 here, minus 6, which ends up being 18, which is equal to negative 1 over 9. All right, that was C. Now, is it local maximum, minimum, or neither? Now, since the second derivative is negative, okay, since second derivative is negative, while first derivative is positive, or is equal to 0, this is basically, this tells us that the point is, imagine this is negative, that means concave down this way, so therefore the point is maximum, local maximum. Right? And this would be the reasoning right over here. Alright, great. Now we have number 5. The graph of f is given with 3 line segments and a semicircle. And then g of x is basically the area from negative 3. From negative 3, and we're going to figure the rest of them out. Now, what is g of 0? G of 0 basically means from negative 3 towards 0 of f of t dt. In other words, we just have to find the area from here to here. Now, this is a trapezoid, isn't it? We can kind of use this trapezoidal rule, if you think about it, with one trapezoid. Then this becomes, area is what? First base, which is 1. Second base is 2 times the height, which is 3. So 1 plus 2 times the height, which is 3, divided by 2, which is equal to 4.5. Now, what is g prime of 0? Is simply f of 0. Because when you take the derivative of g, we will get f. Now, f of 0 is 1, so we'll end up getting 1 as our answer. B, find all values of x in the open interval from negative 5 to 4. Open interval meaning not including the 2 endpoints at which g attains its relative maximum. How do you find the relative maximum? Relative maximum is found by g prime, first of all, of x has to be equal to 0. And also, it goes from maximum dimension of positive to negative. Where do you see from g of x to be equal to 0? G of x, g prime of x equals to 0. That means f is equal to 0. F is equal to 0 right here. Right here. And right here. But you will notice that where do you have f of t goes from positive to negative, which results in maximum. This one is negative to positive, so it will be minimum. Positive to positive, so it's neither, nothing. Positive to negative, right over here. So it looks like 1, 2, 3, when x equals 3. Now find absolute minimum. How can we find the absolute minimum? Now, absolute minimum, notice it is going from negative 3. So when you are here, let me try to use the other marker. When we are here, as you go towards this way, everything is positive area right here, including here. So therefore, the value of g of x will keep on increasing because area is positive. We have a small negative sign here, but it would be very small to cancel out any one of them. On the other hand, when you go backwards, imagine we end up getting into this place by adding this much of area. In other words, f of g of 3 is here, but g of 2. You see, from g of, negative 3, I'm sorry, negative 4, I guess in this case. Change of numbers. G of negative 3 will be the result from g of negative 4 by adding some value. That means g of negative 4 must be less than g of negative 3. You see, g of negative 4 must be less than g of negative 3 because you will get to g of negative 3 by adding the area of the triangle. So therefore, our absolute minimum here becomes g of negative 4 because g of negative 4 would have been, as you can see, that's the only minimum value anyway. Minus area of the triangle, which is simply equal to 1. Another way of writing it is g prime of x, or g prime of negative 4 is 0, and then it goes from negative to positive. That means it's the minimum. Now, you'll realize that this point is then very small, but this one, as you mentioned, you have a bunch of positives and a small negative. That means this, g of 4 will be far larger, and g of negative 5, in fact, will be same as g of negative 3 because the areas will be the same. So the lowest point would have been g of negative 4. Now, number D. Find all values of x in an open interval where has a point of inflection. Now, D, point of inflection, basically means, yes, from the original function, double derivative, right, generally speaking, of f of x. I know that f of x is not here, but generally speaking, f of x, then that means double derivative has to changes its signs, positive to negative or negative to positive, or its first derivative has relative min or max. That's when they have point of inflection of the original function. Now, we'll be using that concept here. Then let me try to use different color. How about black? Where do we see relative minimum or relative maximum? One point is right here, another point is right here, another point is right over here. 3 locations. So find all values of x. Now then, that's when x equals negative 3. And 1 and 2. For this reasoning. All right. This is the differential equation question with the slope field. Now, let me try to use this one. What are we going to do? Find, so as you can see when, actually I'm just going to use this one. When x equals 0, slopes are all horizontal. So x equals 0, that means what? When x equals 0, which is y-axis, slope is all equal to 0. So we can write it this way. Now, another place where slope is equal to 0 is when y is equal to 1. Y is equal to 1 is right over here along this line. So that's equal to 0. That's equal to 0. Notice that because of x squared, no matter what, either I have positive 1 or negative 1, it wouldn't make any change. It wouldn't make any differences. So for example, whatever I do to 1, I'll do exactly the same thing for negative 1. That's only because x has been squared up. If it wasn't the case, then we wouldn't do it. So here the point was 1 comma 0. So 1 is here, 0 is here, then we end up getting negative 1. Slope, so slope looks like negative 1, and I'm just going to put negative 1 here. How about in this case, 1 comma 2? So 1 comma 2 seems to be 1 and 2, then the result will be positive 1. So positive 1 right over here. Now 1 comma 3, then this portion becomes 2 and 1. Slope is 2, so I'm just going to make it steeper than this one. I'm just going to make it, oops, steeper, steeper. Now, that was part A. Part B. While the slope field in part A has 12 points, now we just have to write it up where all slopes are positive. How can you have slope to be positive? Now I'm just going to write down the answers here. B. Then dy over dx has to be positive. That means x squared and y minus 1 has to be positive. That's only possible because x squared will always be positive except when x equals 0. So therefore, one condition which we have is x cannot be equal to 0. But how about y? Since this is always positive when x is not equal to 0, this one has to be positive in order for the whole thing to be, the product to be equal to positive. That means y minus 1 has to be positive. That means y has to be greater than 1. So all the points which satisfies these two conditions will be our answer. That's B. Number C. Find the particular solution and notice the initial condition. That means that will f of 0 equals 3 will give us the hint for value C. Since the expression was dy over dx is equal to x squared and then y minus 1, what we can do is we can separate the variables. That's the first step. So we have dy over y minus 1. As you bring this one down, dx will be multiplied to the other side, x squared dx. And as you take the integral on each side, then we should be able to get rid of dy and then dx. Here we have ln of y minus 1. Here we have x cubed over 3, and then plus c. We have no idea what the constant would have been in either case. But we realized that when you plug in 0 for x, y will be 3. So in other words, ln of 3 minus 1 will be equal to 0 over 3 plus c. Then you will realize that c will be equal to ln of 2. So there we have it. Then our expression becomes ln of y minus 1 will be equal to x cubed over 3 plus ln of 2. Then in order for us to get rid of ln, we're going to raise by e. Then we have y minus 1, which is equal to e to x cubed over 3 plus ln of 2. Then y now becomes e dx cubed over 3 plus ln of 2 and adding 1 at the end. Now, so this will be good enough, but if you wanted to simplify even further, knowing e and ln, I mean, even though this was good enough, you could have put it this way: e to the x cubed over 3. Addition in the exponent means multiplication, so e to the ln of 2 plus 1, and this portion becomes e and ln cancels out 2, so therefore another way of writing this answer would have been 2 times e to the x cubed over 3 plus 1. That would have been our final answer. That's it.